Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger. It's been a while since we recorded the stream, probably a week ago. And yeah, the reason was that I got other things to do, like school and stuff like that, yeah. But now we're back, and let's continue. Okay, so please, if you have any questions, post them on Twitter or YouTube, and I'll be there to answer. Alright. Um, please make your questions related to the thing we did today, or what we are gonna do today, because I haven't tell you what we're gonna do today. So yeah. So let's go and open the project. Uh, open the console. And let's say that we'll open the project. And let's compile it. And let's see where we left off, because I've been sincere, I don't remember. It's been a week. So let's open the debugger. And this seems like it doesn't compile at all. What's going on here? There we go. It was cold. Now it's getting warmer. You know, the computer needs to put the thing to move on here, you know. Even MS-DAV is not... Oh, okay, there we go. I was gonna say it's just getting started. And that's the reason why it's too slow to open this. But even though, you know, it's really slow, you know, you cannot argue against it, you know. It's just slow, Visual Studio is slow. And yeah, it's too bad. So let's go and open. Let me go and open the project. And we have to wait a little bit more, because Jesus Christ, opening a file, it's just the hardest thing to do for a computer. And yeah. Okay. So if I remember, I mean, I'm just like by just trying to wait here. I'm just starting to remember all this stuff. So yeah, I mean, the last thing we did was like, well, we left it on a normal state, if I do remember. And the thing that we were planning to do after the last stream, if we can say that way, is that we have, I mean, we already have, like, semantically speaking, you know, our a basis, you know, the, let's say, our usage code for what the disassembler is going to look like. You know, the usage cases, you know, all this part here, you know, it's something that we have worked throughout the series, you know, disassembling one instruction at a time, and seeing how this API starts constructing itself, you know, because that's the way it goes. So that's the thing we have done throughout all these streams, and now the thing that we have left to do before continuing, of course, to making more features and stuff is that we have to think about the code. We have to see the semantics and start compressing it. Just a standard compression-oriented programming. We have to think about the semantics, see about patterns repeating themselves in throughout the code, and start compressing it, just like an effective compressor. So that's what we're gonna do today. And let's see if this already opened. Yes, it did. So let's run it. Now we have to wait another moment because running this is gonna take Jesus Christ, it's so hard. It's just so slow. What's going on here? It's like if I haven't opened the computer like for a long time. It's just like, oh, I'm trying to wake up here. It's like, dude, I worked with this computer yesterday. It's just like, it's too sad. Okay, so there you go. And yeah, we initialized the. There you go. And I don't know what instructions we just put it. Let's run it completely, and there you go. And we have that stuff left there. And these are our last instructions. This is our instruction stream. Pretty simple stuff. And yeah, so the last ones were some pushes. That has probably we were working with. How these pushes have the operand inside the main opcode. So yeah, we were working with that. So that's the last thing we did, these instructions. And the other stuff is pretty much the same. Some REX prefixing working here, all the addressing modes as well working here, some floating point instructions as well here, some 3 byte, 2 byte, 1 byte tables instructions as well here. So we have a little bit of everything. Let's say we don't have EVX right now, but we're gonna leave that to the future. And yeah, so yeah, I mean the stream is pretty much the same. We still have to do something with this thing that if I remember correctly, the reason was that it's an invalid, but well, now it's not invalid at all. Whenever we get the prefix, we don't get invalids. I don't remember. Let me check that out. So I'm gonna. Oh, just what's going on? There you go. So get mnemonic entry should be the one in charge of doing that stuff. Whenever we get this is gonna go out. It's gonna say, well, move the byte, get me the entry, fill the buffer if any, and I will send you as input let's say the context of it. Probably we want to have a context here. Now, okay, that's nice. For this stuff that we haven't done it yet, we should just like put it all in line. So this is the context, the RX byte, effective operand size, and stuff like that. So let me see this call over here. Is this part here, and if I see Jesus Christ, I'm sorry. What we can see here is that we run for this. Let me read this assertion. Let me remember what we were doing here. We have the up table entries, and we just get the entry index first. And we get from the type, from the from looking at the bytes and stuff like that. Yeah, okay. So first we get the table ID, and then we get the entry from the table ID that we pass here. Okay, and then we get the entry, and all this stuff is pretty much for the inline, you see, because this is the entry that we get, and that's all. So if we remember, well, let's go and run it, isn't it? Let me put an instruction there, so we can just stop. Okay. So we have this c by equals 0x3. If I do remember, is the last instruction. Okay. So we already have it. So let's run it. I will stop. Compile. I'll put the breakpoint in there. There you go. We have c bar equal to, let me go to hex. What? No. I didn't man that. It was this. There you go. We have a 3, a 5. I believe it's the last instruction. Yes, it is the last instruction. And let's see what we happens. We get the mnemonic. We should get an entry, a valid entry here. And yes, it is. It's an add, and just we just print instruction out. See, there you go. And we now let me see the c byte, because the c byte it's 00. That should entail that we have an invalid entry, because if you think about it, well, and I close all the Intel information, so that we had before. So let me open it once again. And we have Hammy Hero. Oh my god, okay. And we can just put this over here. There you go. And we will no. I was gonna say yeah, I know. Oh, but we have all the pages, isn't it? Yeah, we have it here in the H file. Here we go. Let's just open 1, 2, 3, 4, 5. Okay. So duplicate this stuff. There you go. And we have to go to the 83, if I can do it, of course. Probably not, because it's already it's trying to open the others. It's too hard for it. And my thought is like, if you think about it, this shouldn't happen at all, you know. I mean, this is independent from loading this, you know. It should be in parallel. I mean, I cannot even move this, you know. It's just stuck there. And now it seems like I can do it. I mean, no, it's totally busted. So, Mr. Chrome, you cannot load a PDF effectively. Or, I'm sorry, you cannot load two PDFs independently of one of each other. That's kind of busted. Totally busted. Totally busted. Can I move this one? Nope. I cannot interact with this one. I cannot interact with this one at all. It's just totally, oh, there you go. It's just stuttering. And there you go. So after a little moment, oh my god, what was that? I want this number. There you go. This is the first one. This is the second one. This is third. This is the fourth. And this is the fifth. There you go. So there you go. We have all the sections that we were reading before, especially these three. And this is just the generic port. I will move this over here. I will keep this in here. It's just effective operand sizes and stuff. Yeah. So now this is not. It should be here. Here you go. So yeah, now I can see. Yeah, it's not incorrect. You know, the thing that we were doing, and the reason is that we have this entry as valid. You know, we have a 00 entry that can be that means an entry. You know, it's an add with EVGV stuff. You know, and that's pretty much it. You know, we cannot just say that it's invalid. You know, we cannot just stop and say, oh, this is not. I mean, if probably we find a no-op, probably could make sense of it, or some other entry instruction or whatever. But in general, you know, we have like a really simple way of thinking about it. So this is not incorrect. You know, the thing we were doing here, it's just like it's valid to have a 00 entry there, and we have to handle it. You know, we have to disassemble it as well. So if we have an REX there, you will have an REX at all. We have, let's see what we got from the get mnemonic. We assert that, and then we get the table ID. It should be a 1 byte, because there's no reason why not to do the 1 byte. And there you go. We got the table, we get the entry index from here. And if we see the value, I'll see what's it is, 20, and we're looking at the table ID, one byte table, you know. We have eight entries inside that table, and or inside that group. That makes sense. And yeah, so we got an ID. The entry ID is not the same, and supposedly there's a moment where we are gonna match, and probably there you go. We have a valid 26 and 26 thing, you know. It's just this value is totally random, you know. There's no nonsense. And I mean, probably we can get rid of that because we found out that it's just not useful at all. Since what we are doing, we are already. Let me think about that. We are still using the mother m byte, isn't it? Well, we need to get from the mother m byte the identifier. That makes sense. But there are cases when that happens is whenever we have a floating point, we have to fetch the mother m, or we have, well, the mother m is just to say the operands themselves, you know. But sometimes the instruction, yeah, when we have extended opcode and stuff like that, it's just when we have extended opcode, especially when we have extended opcode, we have the entry on the 1, 2, or 3 bytes, but then we also have the entry, you know, that entry gets segregated by the mother m byte to fetch it, you know. So that's the only special case that makes sense. So yeah, I mean, we could still get the same thing without having to have the bits shuffling here, you know, with this hashing. And yeah, I mean, so he thinks that we have that kind of entry just because the way we are computing the match, you know. There's no other reason why we are getting a result by it, you know. And that's the reason why, and we already push it. Now we're not gonna get anything at all because it's just gonna print stuff. If we print it, it's just say, oh, we have RAX, but this is all busted. It's not. And in fact, well, this is push. It's a push. It's not even it's not add, you know. So it's totally busted. So let's do that, you know, before compressing stuff. Let's just get rid of that because we can do it, you know. And probably at the same time we can start compressing stuff, you know. So let's go to the get mnemonic entry, and we're gonna go to the get entry index stuff. And if we remember, we were using this call. I don't know why we have these two. Probably we should get rid of this one. And these are the prefix flags. I'm gonna keep that. What's all this stuff? Oh no, this is all garbage code, isn't it? It's a translator thing. So probably we can just get rid of all this stuff. We're not using it anymore. we're not using this anymore. We have this sign stand. We can keep this probably. Are we using this at all? It doesn't. So probably we can just, well, we can get rid of this. Yeah, because we're doing it inline. Okay, so we're gonna compress the other stuff. So let's get first rid of all this stuff. Is unique flag. Yeah, we can get rid of this as well. We have an address in name stuff, which probably were using before, but now it's not. For the name entry, but this is all busted. Get bits at offset. Shows garbage. Get byte offset. Shows garbage. Get bits. Are we using it? No. So just get. Well, probably we can use it later, but well, doesn't matter. And bit field result. What's all this? Thank you. Are we using this? No. There you go. We erase all this stuff. We want a generic bit field expression with bigger than 31 bit field sizes. Oh, that's all. I don't care. Are we using this one? This is not correct. Or I don't know what we were doing here, but we can just get rid of it. Get ref field. No. Get bat size. No. Fly let subcode. No. And this is the read entire file thing. Allocate memory stuff. Windows.h, standard IO, platform with 32 EagleFly. This awesome, and the P parser stuff. Now probably. There you go. So let's see. We erase some code there. Now we have something. Let's see if we already print this out correctly. Let me put the charger here because it's dying. My computer. Okay, so the thing, oh yeah, let me compare the stream so we are doing this correctly. Push R12 REX PL REX RBX R13 REX times 2 plus 0 0 0 RBX RBP REX times 2 0 0 0 RBX RBP plus REX times 1 plus FFFFF move RBP RSP plus R12 times A plus 0 0 0 3 3 2 2 1 1 0 0 R8 core pointer R12, that's correct. Array core pointer R13 plus 0 0 REX these are not sign extended but they should, so let me copy them. Here we go. Add byte pointer REX FFF0 and this is correct. Fat ST0 ST1 ST1 ST0 FLD core pointer 0004. We have a beam resume. Appeal line R XMM0 XMM1 08 shield door pointer 0000 EAX03 add EAX door pointer 00000 and please hold me a second, I'm gonna just grab my bottle of water. There we go. And now, yeah, I mean, everything looks the same. Nothing has changed, and that's okay. So yeah, at the X door pointer 00, okay, perfect. So that's the first thing we did. We just erase a bit of code there that we were not using, and so we can continue. So now we have something that looks pretty much the thing that we are using now. All the calls, get entry index, table ID result, get table ID, stuff like that. Some stuff that gets working with all the stuff. So we have to start like thinking about compressing all these calls. And the first thing, let me see if we can get rid about for the hash from the hash, you know, just because I mean we can start by there and then we can start compressing all the stuff. So get entry index, here we go. So before we were doing this hashing here, and I would like to see we were using it for both, for generating the entry index, or the ID in this case, because yeah, I mean, if you think about it, we don't have to. Let me go to init. This is our initializer, and these are the things, the bytes that we are using right now: OF, C3, O40, O5, E1, C1. Well, I'm just gonna wait a second. We don't care. I mean, it's not like too much of a hurry to do this, but I'm just gonna keep it that way, and let's start to think about the compression part. So we can just go straight down to think about how to compress all this stuff. I mean, yeah, we can go back into this. I mean, it's not like the end of the world. We just keep it that way for a moment. And let's start by just, I mean, we are on the mood of just erasing some code, and that's what we have to do. That's what we should do. So, yeah. So the first thing I would like to see is, well, what can we compress? And let's see. What can we compress? What about the operand size attributes? We haven't done anything yet about it. Okay. What about? So these calls work. We have the idea. We break the decoder process in 3 steps basically. We have the fetch register operand, which is this one. We have the fetch memory operand, and we have the fetch immediate operand, and that's it. That's all we have to care about, and we have found a way to work with it. We just add the things that we need so that it's just working, and we have the code that represents that stuff when we have it here. And we have here, whenever we fetch the register operand, the register operand is we can call it like modal way. It works in different modes depending on if we pass these things over here. So the first thing I would like to do is to have a struct for them. So I'm gonna call this modern context. Yeah, I mean, it's not the mother RAM itself. It's more like the context itself. EagleFly opcode context. EagleFly decoder context. Yeah, EagleFly decoder context. Yeah. Let me think about this. Yeah, I'm gonna call it decoder. And basically I'm gonna pass all this stuff. And this stuff as well, probably. And let's start by there. Right. And we could choose, well, let me think about it. Fetch model and by, it's used, let me see, it starts here, it goes here, and here it's in the fetch register open thing, which is just pass. Fetch and fill as well, it's just pass. Fetch model and by, then we'll counts back here on the memory operand, and here we don't pass it as a thing here. Well, but we pass the effective address size and stuff like that, and the effective operand size. Now the effective operand size, it gets passed on the entry. This also as well, it's something that we have to compress on there, but I was hoping it to see. Oh, it's because we make the resolution before, isn't it? Because we use it here as an effective operand size. Oh, we pass it. Yeah, we pass it. And this just cares about the effective operand size. Okay, so yeah, I think we can add the effective address size as well there. You know, effective address size. Just a thing that's gonna be happening over here. Here you go. Fetch more and by, fetch and fill. And yeah, we can start by there. Let me see something else I'm missing. Effective operand size on the fetch memory operand, we use it. Here's where we modify it at the first pass, and then we use it on the mnemonic. We use it on the mnemonic, that's important, because on the mnemonic, well, get mnemonic, and here you go, we have the effective operand size, and we use it for yeah, it's just a special case or whenever we got an operam. And here we pass the REX byte as well. That is something that we got on the first part, you know, we get REX byte, and this is, we got it from the disassemble state on the REX byte. So yeah, if you remember, we had, I mean, we before we got the context in line on the disassemble state, you know. Here we go, which is all this stuff, you know. We have REX, the current up byte, the current entry operand. This is the thing that we were working with, the like the context, you know. This is our context to work with all this stuff. We want to keep it that way. Yeah, I mean, right now we don't have a reason why to decouple this. Let me think about it. I mean, we don't want to have two contexts at the same time. If we wanted to, then that's a good reason to decouple it. But yeah, yeah, I mean, there's, it's not bad, the thing that we have here. It's okay. It's just like, hey, we're passing all the things you need whenever you need it, and you modify. So pretty much this is the thing that we have as a context. We have the entry itself, we have the thing. So what I thinking is that, what I was thinking is, like, if you think about it, well, the entry just serves the purpose of being used for these three calls, you know. That's all he cares about, you know. The entry doesn't need to, it's not needed by other stuff, you know. If we needed to have it other places, then probably it will be okay. So what I'm thinking about is, like, hey, what about just say this, or even, and this is not a pointer anymore, it's just a thing that is stored. And the good, nice thing about this is now is frame independent, which, I mean, right now we don't have any problems with frame dependency, but we can just keep one of it, one entry as before, and we don't have to have a pointer of it, you know. We can just have it, since that is what we use. So the get mnemonic entry is just gonna be used like this, and that's it. So what about that? That's our first change. Let's compile. And I'm gonna call it entry. In fact, we can still have a pointer to it. It all depends, because right now we haven't thought about any file input IO, you know. So we haven't thought about like how it's gonna work that stuff, or how we're gonna get the entries themselves. If we wanna keep it on memory, or we wanna get rid once we get, well, we can just load it, and yeah, yeah, but we still want to have a cache, you know, some kind of thing like, hey, we have this, and now here we don't need this anymore. But I can say I don't know if we have a type of it. So how can we do this? Uh, uh, what I'm thinking about is like, I mean, right now we don't have any difference, but I'm thinking about the future and how uh, we want to pass this stuff onto it, you know. because yeah, we want to have a stack frame so that we want to can use that. That's what we want to have, a stack frame. All right. So yeah, I mean, yeah, yeah. Probably this is not, but this is gonna work. This is gonna be useful for us in the future. So let's think about this, okay? I'm gonna move this back. Where is right here? I'm gonna make this a pointer, and I'm gonna just say that, okay? This is the same. This is gonna be good because we can just assert, and we can say this as well. We cannot assert here, but this as an entry equal entry, and then I don't know why we were not making the assert of the entry itself. So yeah, I prefer it that way. Then we can assert it all the time. It doesn't stay the entry. It doesn't stay. We do that. We do that. We do that. We do. And here we're gonna have the thing. Mnemonic. Alright, so I'm just moving it backwards a little bit. And let me compile back and see if we can have our stream as before. There you go, all seems fine. So yeah, so the stack frame, I'm gonna start it here itself, you know. I'm gonna say EagleFly, how do we call it, stack frame. I'm gonna it was the decoder context, okay. So probably I want to move the context a little to the other side. Color context, I'm gonna move this here. And there you go. I'm gonna move this over here, right there, and I'm gonna start by just moving this one yeah, something like that. Pretty straightforward. I'm gonna get rid of that. Well, probably we can use it later. It's just a thing that we have there. You can even put it, let me put it I don't know why we were doing this CBI thing. So let me get rid about this CBI. We don't need it anymore. And there you go, CBI, there you go. And we have this buffer stuff that we were initializing all the time, and we probably were gonna do something about this, but wait a second, wait for it. I'm gonna move this on the top of it. There you go. What's this? I can get rid of this. So there we go, we initialize the context with that, and now this stuff can also as well come back here. I'm gonna put it just the same way. Alright, check if we can have more than one mandatory prefix. Is that real? I'm gonna put it here as well. And I'm gonna read it down. And this is the context themselves. Well, and let's solve for the errors. There you go. So this is the context. This is the context. The C byte, I'm gonna keep it over there. Right now I'm not gonna pass it, but we're gonna start by there. This is the context. And here I'm gonna pass the context itself. Well, I'm gonna pass it like this, and then I'm gonna we're gonna do something with that, but I'm gonna pass it right now like that, just to make the change in this place, and then we're gonna like how can I say that? We're gonna go inside, you know? If that makes sense. There you go. Let's see what else we have to do here. What else we have to do? So I'm gonna put the context here and the context here. Right here the same. Right here the same. Right here the same. And okay. So if we run this, it should be the same. We shouldn't have any problems. We didn't change. Oh my god. Well, the breakpoint seems to move, just a little bit busted. Oh my god, I cannot take it out. Huh? I want to break one more time. I can't. That's totally crazy. What? I cannot put a breakpoint there. Oh, look at that. This is a bug. I mean, I put a breakpoint here, and the breakpoint appears on the downside. That doesn't make sense. Look at that. I have, what's going on? uh, Let me reset all the breakpoints. There you go. Look at that. I'm gonna put a breakpoint. This is all busted. Oh my god. Okay, that seems that it's just broken Visual Studio, which is kind of interesting. Look at that. I mean, I'm literally clicking where the uh, where the arrow is pointing towards, and the breakpoint appears somewhere else. You know, super weird. So let's close this. It's just super weird. And let's try to open it back again, if that helps Mr. Visual Studio to repair its fall, which is unrepairable. Okay. Come on, Mr. Visual Studio. You got the breakpoints. Do you have correctly kind of put a breakpoint? There you go. It's back. So yeah, I mean, it has a book. Now we know that it has a book where whenever we recompile, sometimes the PDBs are just busted, or probably not the PDBs, probably it didn't upload the new PDB, probably with the proper light indexes or the call stacks or whatever. I don't know. So yeah, come on, come on, come on, come on. There you go. So that was a little bit weird. So let's try to put a breakpoint here. There you go. And if I see here, we still have the same idea here. And yeah, I mean, there's no problem with that. Let me drink a little bit more water. And yeah, I mean, nothing changed. We just have done pretty much anything. We have just grouped something there. And yes, yeah, so let's continue with this. So now that we have the context on which we can work with, we can just say, well, you know what about if we say, well, we're gonna pass the context here, and in fact we can also put the rex byte on the context. It's like, why not pass the rex byte on the context. I'm gonna say right, where is the context here? Context rex byte, of course it's gonna be nullified, so that's okay. And I can just erase all this stuff. We don't need it. I'm just gonna say context rex byte c byte. Then we got the fields to make the resolution of that. That's okay. And we move c byte as well. So then we can just pass it here. Let's compile. And we also use it here to pass it on there as well. There you go. And if I run it, it's just the same stuff, you know. Pretty straightforward. Nothing weird going on there. And yeah, okay. Rex passing. Okay. So now we can just say, well, let's think about how to pass the context, because we can pretty much get rid of this stuff, you know. We cannot say we don't need to do this anymore. In fact, we can just do this like this, pass this like this, and pass this like this, like that. And what I'm gonna say, I'm gonna go and say that I need this. I'm just passing the context, and I'm gonna pass here the context as well, yeah. And I don't gonna erase right now. I'm just gonna pass it as well, so I can construct it. So right here, I'm just gonna pass the context, and I'm gonna solve it downwards, you know. So let's see what we need. Context effective address size. We can just get rid about that. We can just get rid about all this stuff, and we can just, this doesn't need the context. It doesn't need the context. Okay, compile. That's correct, my dear. It doesn't have that, and we can pretty much start to do this. Okay, so let's use the compiler to tell us the errors that we have, so we can just solve them. First thing we're gonna see here is that we passed before rex byte and this thing, but now we just have a context. You know, if like context, if like color brown, the color context, and pass the context. In fact, well, we can pass it as a pointer. I don't know, probably just the same. But for now, I'm just gonna do this. I'm just gonna read it about that. Let's compile. And then we're just gonna say, well, you know, this is just the context. This is the context as well. This is the context. And yeah, that's okay. I don't see anything going on here. Oh, something, I just remember something, like, yeah, we copied this from the fetch register open, so we can start compressing some part there because we have the repetitiveness. But first I'm gonna just solve for this, and then I'm gonna compress the code. Alright, So basically, reverse, we have the context, and what else? Compile. We're gonna pass here. What's the problem here? Oh, context. Now let's go and solve for begin. And I'm gonna I'm gonna I'm gonna skip this one. I'm gonna pass to the other one. Okay, fetch memory operand, and I'm gonna pass So you think about it, well, all this stuff can go in the context. I mean, there's no other reason why not to do that. Yeah. So we can just pass all this stuff. And we can just say that, and that's it. Yeah, I can just say extracting operands, but I mean the operand instruction happens even afterwards this, you know. So we can just get rid of all this stuff. The the thing about this is that well, it doesn't matter. I was just thinking like, well, this has to have the modern byte. I mean, we have to assert somehow. I mean, the asserts. I like the assert thing, but the assertion can just happen in line. You know what I mean? I mean, I know. I mean, one thing like I was thinking before is that I mean when we started this is like I want to have like predefined landmarks, you know, or a predefined sections in the code where things can be assumed independently of the decoding, the semantics of the instructions themselves, so that we can, I mean, normally, it's not like a thing, but I mean, in most architectures, independently of the decoding process, you're gonna have uh, I mean, in most cases, you're gonna have this kind of idea of mnemonics and operands, and that's the idea that I wanna keep on doing. I wanna keep that idea so that if we wanna do in the future, I mean, probably I don't know whenever in the future, but if we wanna expand the disassembler to be a disassembler of multi-architecture disassembler, then it will be pretty easy to do that because we have thought about the needs. I mean, probably, we're gonna need to do the whole stuff of understanding the data, the encoding process, but we can get to have the same mechanism to decode that stuff, disassemble, let's say ARM architecture, MIPS architecture, or whatever we wanna do. We can just pre-do the only thing that we have to think about in the future is just to think about the encoding. Let's say, okay, what's the thing we need? Even the probably, I'm saying that probably the table is gonna be. The only thing that's gonna change, or the ideal thing that happens, is that the only thing that changes could be the tables. That would be the nice stuff about it, instead of changing the whole disassembler process. So that's kind of an idea that I like. I am trying to figure out. Of course, we cannot like make sure until we see other architecture and compare against this architecture to see how they differ, and how similar they are. Do they have operands? How they are, the syntaxes, the encoding, etc., etc., etc. Which is, of course, something to think about. But for now, let's just think about a way to facilitate that in the future. Even though we probably don't do it right now, we can have an API that expresses itself in that way. Lets us. It doesn't closes that opportunity for us to expand the disassembler to other architectures if we want it in the future, and that's something nice. It would be something cool to do. I have some ideas about it, but it's just like, the first thing I thought about, the first thing I think about, or the idea that I have to start with about that, is just to have this real, to make sure that we are on the same page, whatever we are. Right here I'm decoding operands, right here I'm decoding mnemonics, right here I'm recording prefixes, if any. Right here I'm decoding whatever that the architecture has. I want to have like these semantics going on there, or at least it's not like I want it. It's just like I found that's kind of the thing about the decoding process that happens, or that's something that we found out across doing that kind of stuff. It's not like, oh yeah, it's not arbitrary. It's something that happens with the practice. So yeah, if that makes sense. So the thing I was like thinking, where is the search stuff? I was just, oh my god, there we go. So let me compile. The begin operand instruction. Okay, so we have a bunch of asserts. The asserts are okay, they are good to have them, but we can just have an inline. We don't have to store this stuff anymore because we already have that on the upside, you know. So what we can do is just pass it as well, you know. And I'm gonna say here fly the color context. We have the cbyte, we need the entry. And that's pretty much it, isn't it? So we can just get rid of this. I'm gonna keep the asserts. I want the asserts. I don't know if I want them here or I want them in line. So I think I'm gonna pass them in line. Or I can even, I have an idea, you know. Well, I mean, I cannot have asterisks here, or at least in the way we have it, it's just happening in the same way. But this is just like we don't need that. We have an open offset. I don't know if we want this in the future, but I'm gonna keep it that way. Okay, okay. gonna call this, it's not gonna be any operand offset anymore, it's gonna be just by count. But well, I'm gonna affect the operand size, or how I call it, and then I'm gonna call it by count. Okay. So I can go step by step. So I think that's all. Now let me see the pattern usage of the entry thing. We got the entry, we use it as a user, and we just use it there. Are you serious? That's super weird. I mean, we got all this information and that's all we need about the entry? No, look at this. No, this also use the entry, okay. I was like, what? And this is the initializer, yeah. I was like, where's the entry stuff? Here's the entry. So it's just the modern present, modern count, direct type. Most of it is just rec offsets. What about this? Is the entry, the operand size. We modify the effective operand size. So yeah, well, yeah, I mean, it can be there. I was just thinking like if we want to have another cache. Yeah, because the usage case is like, I mean, whenever we use this, whenever it's just, we're gonna start using all this stuff. So that's why I'm just passing up there. So I know I don't want to dereference it back again. So yeah, so probably that's good. Check if we can have more than one mandatory prefix. So yeah, I mean, I think this is all we need. This is the biggest one by itself. Oh yeah. So I'm gonna say that. Okay, we can just get rid about that. Fetch memory open. Let's compile. And what's going on? Fetch memory open function doesn't take 5 arguments. That's correct. That's totally correct, Mr. Compiler. Thank you very much. Because, well, we don't need this anymore. We just have a context. And what's the problem here? We have to pass the context, of course, here. This one's the context. There you go, my dear. Of course, further with stuff. I want to change that as well. And let me, that's good to know. Let me erase all this stuff on the disassembler. I can, and the fetch can as well. That's something that we we pass it here. Okay, so the fetch can is something that probably we can get rid of that later, but I'm just gonna pass it onto here. All right. I can just do this. And here and we have all this stuff here. Right now I'm just gonna pass it as well. And now we can just get rid of this old stuff. Um, okay, let's compile. And base size. Oh, okay. So base size is equal to effective address size, and we were playing this around. I see what we got here. So probably this special thing, whatever we fetch the register open, we want to pass it with the whole thing by itself, isn't it? Because, well, probably this can be itself, the context, but we want to keep the effective open size be passed, okay. So if that's the case, we don't want to do this, we want to do this, right? And that's a little bit I mean, I can modify the context as well, which probably is better. Yeah. So let me see where we are using it. We're using it just in these two calls. So we can just say context, effective open size, base size. And here we pass the index size. Since there are different stuff, pass the base size. Yeah, so I prefer to do it this way because it's something that it uses it, like it's really important to it for it to be independent. Okay, all right, so if that's the case, we can pass it, fetch register open. All right. And then what else is going here? Fetch count. Where's the fetch count? Now I don't pass effective immediate size. What we were doing with effective immediate size? We just pass it, isn't it? It has it on the entry itself. So let's just pass the context. Yeah. So entry has an immediate size by itself. It was the table's im size. Im size. So that's pretty much, well, I'm gonna say uh, no, 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 no. So that's pretty much it, eh? Hmm. Let me see. Are we missing some bracketing? We have the for loop. We have an if there. Closes. And let's see. There you go. So now we compile back. So even though it was a little, we made some changes there. So let's see if that runs down. There you go. We have an assert. And since we don't initialize the cbyte, that makes sense. Now the interesting thing about the context, well, the C byte is always moving forward. It doesn't reset. So that's the only thing. And since our context right now is resetting, we probably want to have, well, it's gonna be like the same thing as we had before if we want to keep up with the context. And in fact, well, this C byte that we have, I'm gonna keep, well, I'm gonna go step forwards. I'm gonna keep C byte independent. That's okay. And I'm gonna, and this C byte is gonna be called different. I'm gonna call it it's more like you know what I'm gonna do? I have an idea. Since we're already using the context, we can just make the same idea here, you know? I mean that, like, we open the buffer, I mean the frame stack is gonna start from here, you know? Yeah. Yeah, I mean, we don't have any reason why not to do that. So that we don't need to pass this at all. We just pass the context that we have here, okay? And then we can just do it like this, you know? Now we have something like that looks pretty pretty much the same all places, you know? We just pass the context and that's all we should say. And that way just do this like that. And that's all she said. Yeah, that's all we need. And then I'm gonna pass over here, and I'm gonna pass out entry. I'm gonna need C by. I just need that and that, and then I don't need to do this anymore. And I don't need to return anything at all. And then if I compile that, this C byte stuff, we can just use the context. Yeah. Now let me think about this. Yeah, because here's where we copy. So we just say context C by, and in this way we get rid about the pointer stuff, you know. Context C by now get table ID, pass the pointer, and it makes the resolution with offsetting, which is nice. That's the only thing we care about. So yeah, I believe. Yeah, we pass in the main of by and makes the references all over the place. Okay, so that's good. And here in that case, where is it? No, get mnemonic, here we go. That's the way we're working with. That's pretty much it. Context C byte, context C byte. Now where do we use the main of by? Is that all? So we don't need this. And then we pass. Why we use the offset? Oh, it's because okay, I got you. Yeah, we're gonna compress this in a moment, but I was like, what? Okay. And yeah, that's the whole thing. We just say, we pass the context C by here, and C by thing here, C by. Yeah. I mean, we can still keep this one, you know, like this, and we just use that one here because we just think. We just need the value, of course. If that makes sense. Here's the only place that we need to use that in that way. That makes sense. But in that case, I mean, I don't feel any reason why not to do this that way. So we just have to think about once, and that's it. And I can just get rid of that. and let me compile and look at them. There we go. And the entry here, this is the context entry. It's gonna be a copy of it. Okay, we're just gonna copy there and just store it for the context to be used. You know, it can be a pointer, but whatever. I mean, if you think about, I mean, since we use it a lot, you know, we don't want to go dereference it all the time. We just want to dereference it once, and then if it fits the cache, which we haven't checked that, but if it fits the cache line, sorry, it's good, you know, because it's the only thing we need, you know. If it's the cache line with the other data information on the context, you know. So yeah. That's pretty much it. I don't know what else here. Context, entry, operation mode, and I'm gonna keep that here. Context entry, context entry, well, thank you, Mr. Compiler. That was a typo in here. I can just get rid about that. Now I don't know why do we have it there. It should be there. And yeah. So now we know, hey, we are now on the modern by, you know. That's where we want to go, you know. We want to modify it and we want to pass it over there. And then context by, there you go. And I think that's all. This should return value anymore. And now we compile. Alright, so if you see here, I mean, there was not a lot of compression, but it was something necessary to do to accomplish what we're gonna do next after this. Okay, So let's see what we got. I'm gonna go step by step, uh, step by step, step by step, step. So let's see here. You know, we're using cby. We pass the context. We initialize the context. You know, I'm gonna see the context here. And let's see what we can do here. You know, we have an effective address size, apparent size. We don't have an apparent offset. We have fetched the mother and by. And what's that? Yeah. If we have an rex, context rex by, there you go. The rex by is pointing to 41, which is correct. We got the context, we modify it, there we go. And then yeah, it's null. Okay, so we had to pass the context cby. So right here we have to initialize it. All right. And then, well, we're gonna use the context cby over here. And then that's the way it goes, and that's it. So this is our frame stack. You can see we initialize the stack and then we pass whenever we are done with it. We copy the value afterwards. Okay, that's pretty much it. I like that. Now let's see if we are missing something here. Probably not. So cby, now it's pointing towards something decent. The other thing is just pointing to the same places. Now let's go and look at that. There you go. And then the context entry, it's just a push, same thing as before. Push string to buffer. Okay, the buffer R12. Okay, now fetch the memory operand. We'll have mother and prison. The operand offset is 0. What about this? Raise the operand size. And we just return because the fetch count probably already worked or something. Or the operand size just busted. No, we don't have a mother RAM. So it's just the mother RAM that's working out here. Okay. And then fetch immediate, operand offset, operand instruction. There you go. Now C byte, it's pointing towards 50. That's correct. It's totally correct. You get the mnemonic. This is another push. We'll have an REX. Push REX. Okay. What about C byte now? We're on 40. That's correct. Move SPL RSP. I don't know. I mean, we should we should have the thing here that we had before. No. Yeah. And this is incorrect. Which is REX, not RSP. So something's busted there. Something's busted. So let's go and solve it just straight on. Let's see what happens. What happens in there? Okay. So we can just run it, I guess. It's on the third one, isn't it? Yeah. There you go. So let's go and do it. You know, we are on proper C byte. It looks like we're on 40. And then 84, that's correct. We have C byte, we have REX, and we don't modify the effective address nor the operand size. Now we're on other byte there, 8A, which should be, yeah, that's correct, 8A. We are on the mother RAM. Let's go. No, sorry, we're on the main dump. So this is correct, I believe. We're on 20 now. That's correct. And we got the entry, which is a move. That's correct. Okay. Now we got, and let's go for the fetch memory operand, because this is the incorrect thing. So yeah, so let's enter the, and we got the entry, we got effective address size, and the effective address size is 8. We got the mother and prism. So this is a memory operand which has it's a base. Well, it's just REX, isn't it? That, well, of course needs an REX, but it doesn't need REXW. Sorry, it needs REXW, but it doesn't need. So do we have REXW? It's 40. That means that we don't have REXW. Okay, no, sorry. So the effective operand size is gonna be 32. That's why we have SPL. Okay, so that's correct. We have SPL for effective operand size. So the effective address size, it's correct. It's 8. So the displacement, the effective address size is 8. The base size is invalid. SIB is false. Then we'll go and switch for it, and then say, well, you know, the displacement is going to be invalid. That's correct. We don't have displacement. The push string, we don't have SIB byte, you know. So we go for the index size, and the index size is 8. That's, oh, look at this, feature and fill. Where does that thing come from? Oh, look at this. We have this coming from here, you know, which is kind of interesting. So we're not modifying the context. Okay, so that's the problem. Okay, I see the problem. So it's some fetch memory operand. No, yeah, fetch memory operand. We happen to have this stuff, you know. There you go. Let me compress this a little bit because we don't need this anymore. So I can just say this. There you go. And then this we don't need it anymore, which I thought fetcher and fill, and we pass it over all the time, you know. We are like, hey, we have to fetch the R and fill, but here we have to pass the context as well. Now that we have them, because we use the context now, and we want to make sure that that happens to be used equally here, you know. We have here, where is it? Is that all? No, right here. Okay, so this is the context, and this is the context. Okay, fetch mother and by, and that's pretty much it. Okay, fetcher and fill. This has to be like that. Now let me think about this for a moment, because while we were doing this changing, This is for the SIB, so I understand that. I mean, for the SIB, whenever we pass the, normally on the basis in here, we are like saying, oh, fetch the mother and bat. That's true, and the fetcher and fill, it's gonna gets us to fetch the memory, which is like the assumption that we make first. Then that's correct. Then over here we nullify that stuff because we don't want the mother and by. Yeah, it has to be false. Well, I'm gonna do this. Yeah, and the arm field. We don't need it because we are gonna use the, let me see, we have the RM field. Well, yeah, okay, yeah, no, I'm sorry, I was getting confused because, yeah, we mean RM field, but in fact it means, it doesn't mean RM field. I mean, probably calling it RM field is incorrect. Probably we want to change that because what we mean about RM field is either the RM field on the monogram or the base on the on the on the SIB by, so it has that duality that we have to think about. Of course, we didn't have a better name to call it. That's why we call it fetch RM field. But yeah, I mean, I don't have a better name for it. It's just like fetch. Well, we can call it like fetch the memory field. Well, it's because, I mean, yeah, well, it goes to the same thing. Fetch the rightmost one, can be. Fetch the center one, fetch the rightmost. Yeah, I mean, it's kind of weird, but I mean, it works. And yeah, I mean, I would like to have a like a better name for it, but I mean, it's understandable somehow. Yeah, of course. I mean, a better name will be better, of course, but when we find it, we will change it. Okay. So we change the context here. Yeah, or both first. Yeah, because we now wanna go for the we go for the SIB byte, and here we're going for the base. We're going for the base, and let me see. Yeah, we got the base. Look at this. Look at the base. We got this fetch base register thing, and we use SIB. We use this thing here. We use this thing. Oh, we were using this thing, but now we are not using it. Okay, so yeah, we need that. Right, and then okay, here we nullify all that stuff, and here we want to make sure that the iron field that we are looking for, it's true, because the index, that's a little bit weird, because, well, let me make sure. Fetch register operand. If we go fetch the iron field, alright, we go we go for the RM, or we go for the rec, okay? Else, if we go for the iron field, we go for the index. Okay, isn't that busted? Let me think about it. Because the iron field goes for the base, yeah? Oh, okay, I see. No, it's correct. It's because of this weird looking thing. I mean, it probably is the same, I guess, because the order doesn't matter at all. You know, we have EAX, ECX, EDX, EVX. But since we have the index here, and we have the iron field here, that's why we have it that way. Okay. I mean, I don't have any problems with that, but it was just like, well. So, I mean, even though, I mean, I think I have now the name for it, you know? It's like fetch rows or fetch columns, you know? It's just like it. It's like fetch rows and fetch columns, you know? I think that's a better name. Because I was like thinking, well, you know, and that's the reason why this is fetch iron field. So I'm gonna call this fetch rows, fetch columns. But before changing it, I just wanna see if this solves the problem. I don't see any fetch iron field. Well, another fetch iron field. I don't see other fetch iron field, so let me see. Now fetch register operand. Yeah, here we just pass it. Okay. So let's run it now. So let's see what happens. We have R12, REX, that's correct. And then then we go for the memory. I want to see the context, of course. And 84010 fetch iron field. There you go. We assume that it's true, and the fetch modern bytes just the same. And then over here we go fetch iron field is true. That's correct. There you go. Now we have REX. There you go. And print out a context. And and we now we have that wrong. We have AL wrong. So let's go back and check that well as well. So let's see. Yeah. I'm gonna continue. Oh, hold on a second. One more time. There you go. So let's go here, and you know what? I know what's the problem, isn't it? The problem is the stack context. I didn't remember that when I was like modifying the stuff. But yeah, the problem is that we make respect. I mean, we don't want to save the context for different stuff. That's why we pass it all onwards from the same base. So probably that tells me that we don't want to have a context. I mean, we don't want to have the address size and operand size being overridden inside the context. We want to just keep it, I mean, playing around fairly because that's the way it goes, you know? Hmm, that's nice. Okay, so we can make that change pretty easily. So the thing about the context, it was more thinking towards the other stuff that we really want to have a context for it. But effective address size is not part of the context, you know? So we go to here, and this thing just is gonna be gone, right? So let's solve the whole problem side here, you know? We're gonna pass it here. So that's nice because that's gonna solve the whole set of problems, you know? And effective operand size. Right here, we just need the operand size. I don't know if we pass it the address size. No, probably not. And this is like this. This is gonna be called like this. And this is gonna be like this. And then like that. In fact, we're already passing it here, so that's nice. So we can just, instead of passing, we don't have it here, that's correct. That's good. And then the modern byte, hmm. Neither the modern byte, isn't it? Because yeah, the modern byte goes outwards on the thing. Yeah. So all this stuff cannot be part of a context. You know? You know what I mean? They have to be overridden every time we go out of a stack. So they should be used, yeah. Because if not, we will need to modify it all the time, which we don't have. I mean, we have, if we have the context, it will be more complex because the stack wouldn't help at all. That's the reason why we have the stack to just going downwards is when we modify, depending on the necessity. But upwards, the state of the stack is just the same, you know? Okay. Now, that doesn't mean that we cannot group it, but we want to pass it not as a pointer, but as a value. So this is EagleFly flags. And that's pretty much it. Mm. I'm gonna well, I'm gonna pass it here. Right? and we have to pass here. Doo -doo -doo. Okay, here we come. Yeah, I mean, I already know that there was this problem that we were doing this. Now let me think about it. We probably want to do this in any other cases. I mean, the simplest thing to do is just to override this, but it would be a little bit hard to think about it, you know. It's just easier to pass the operand size by itself. So yeah, I want to pass this like this, and I want to pass the flags as well. Okay. Okay. And then So yeah, I mean probably that tells me that we just want to have that play around freely, you know. So I'm just gonna pass it the whole thing without thinking too much, you know. Where is it? Yeah, here we need the operand size. We need the context. That's correct. And I want a context here. I want that thing here. And yeah. And the flags. Like that. Right? And then here I want the context. Here I want the operand size and the flags. Now we have to think about if that's the case, we will just want the operand size to be independent, I guess. But just hold me there. Yeah, I guess that's the case. And here we just need to think. I'm just gonna pass the context, and here it's gonna pass the context. And here on the initializer, I just want to think we're not gonna need this anymore. We just have this downside. And fly decoder flags. And this way, now flags, I don't know, fetch aren't fill. What's the other one? It was false. And that's all, isn't it? The problem, I mean, the only thing is that, I mean, this serves the purpose of the register operand thing. And yeah, I mean, the register operand is the one that passes the flags as well. You know, I'm just passing here flags. And yeah, as the stack tells me to. Fetch and fill, no, we're going for the rec. And I mean, that's it. That's nothing more to it. And I probably wanna move this as well. So let me move this here. and it's the flags as well. It needs the Now this doesn't have a problem because we are not passing the you're passing the size here, you know. We're not passing the flags at all. So that's probably much of it, you know. So we always get this stack based upon the I mean, because the stack is the simplest thing that we use, and is the ones that we should respect for the flags themselves. The context in our case serves for happening to have a stack frame to the other things. So we already have that. We just needed to understand it, you know, because it was like we have a bunch of data, but now we have collapsed all this stuff into two different stuff that happens inside our decoder process. This information is needed by both of them, but they respect different ways of interaction with them, you know. So let's see what happens now. The where is it? Fetch memory operand. This is the most complex one in the sense where it modifies the flags and stuff, but in the other sense it's just the same. Fetch and fill, fetch and fill, fetch. Yeah, that's it. So let's run this. So we got the mnemonic, and it's a push. R12. That's correct. That's correct. And then for the next one, we pass flex. We got another push, and now we push REX. Okay. And now here, which was the problematic one, just fill it out once again. And get the mnemonic. Okay, we have a move. If we go here and fetch it, flags, we have every size, operand size, motor and by, fetcher and fill. There you go. We have a buffer which is REX. That's correct. And then the fetch register one. Now we're using the flags, which is the thing. And here we're using the flags, we copied it, and then we're fetching the modern by we're not fetching the iron field. We're fetching the there you go. Now we have SPL, that's correct. So there you go, we have move SPL REX. Now we have RBX R13 REX times 2 blah blah blah, which I don't know if it's correct or not, but let's check it out. Here we go. No, it's not the system. We have RBX R13 REX times 2 0 0 0. Okay. Let's run this again. Let's see the C byte. It's on 48. It's a modern byte, so that's probably correct. I don't know where we are, but probably we are on it, this one. So let's see it. Move RBX RBP REX times 1 plus FFFFF RBX REX times 4. No, we don't have that anymore. We haven't gotten there yet. Move RBX REX times 4 0 0 0 3 3 2 2 2 1 1 0 0. That's correct. Move RBP RSP plus R12 plus times 8 0 0 3 3 2 2 2 1 1 0 0. It's the next one. It's the next one. RSP plus R12 times 8 plus 0 0 3 3 2 2 2 1 1 0 0. Okay. And okay, so let's see. All right. Now I don't know if this is an OB. I don't know, let's see. Oh yeah, it's an OB, okay. Add by pointer rex plus FFF0 OB REX RDX RAD door pointer REX 0032221 RA core pointer RAX 0032221 core pointer R13 plus 000 RA core pointer R12 RBP RSP plus R12 times 8 plus 00322 1100 RBX RBP RAX times 1 FFFF RBX RBP this is the same, yeah, REX or 12. Fucom, Fath, VN resume, FLD, core pointer 000. So yeah, that's correct. So that's pretty much it. And you know, the thing, I mean, the change that we did was pretty simple. I mean, we didn't do pretty much a lot of things, but now with that we can do other stuff as well, and we can just use them to continue with this. And yeah, so yeah, so please, if you have any questions, post them on Twitter or YouTube, and I'll be there to answer. Uh, please make your questions related to the thing we did today, and I'll be happy to answer them. With that said, I would say thank you very much for coming, and I will see you all on the next stream. Take care.